Assalamualaikum and hi everyone. We continue our lesson for the second subtopic under electrochemistry. So that is 3.2 Nernst Equation. Okay, Nernst Equation part 1. For the first part of Nernst Equation, you are going to learn how to write the Nernst Equation for a given galvanic cell and explain the factors that affect cell potential. So far, we have focused on redox reaction in which reactants and products are in their standard states, but standard state conditions are often difficult and sometimes impossible to maintain. However, there is a mathematical relationship between the EMF of a galvanic cell and the concentration of reactants and product in a redox reaction under non-standard state condition. This mathematical expression is called Nernst equation. This is the formula of the Nernst equation, that is E cell is equals to E naught cell minus RT over NF ln concentration product power of X over concentration reactant power of Y. Okay, E cell here is referred to the cell potential at non-standard condition. E naught cell is standard cell potential at standard condition. Okay, R is stand for universal gas constant, that is 8.314 joule per Kelvin per molar, joule per Kelvin per mole, where T is referred to the absolute temperature at 298 Kelvin. Okay, N is referred to the number of electron transferred in balanced redox reaction. F is referred to the charge of 1 mole of electron, okay, where 1 Faraday is equals to 96500 coulomb. Okay, at 298 Kelvin and R is equals to 8.314 joule per Kelvin. So 1 Faraday is equivalent to 96500 coulomb. Alright, so this is the Nernst equation. So if we want to change from ln into log, so you have to add a constant, that is 2.303, and then substitute the values of R, that is 8.314, value of temperature, that is 298, and the value of Faraday, F, 95600 coulomb. Okay, and then you have to time with 2.303. So you get this equation. So E cell equals to E naught cell minus 0.0592 over N log concentration product power of X over log concentration reactant power of Y. For this expression here is referred to the Q, that is reaction quotient. So we can simplify the Nernst equation by this formula. E cell equals to E naught cell minus 0.0592 over N log Q. So in the heterogeneous systems, which involve solid or gas, the concentration of the solid or gas is not included in the Nernst equation. Please remember this. Solid and gas is not included in the Nernst equation. So we consider the first example here. Consider this electrochemical cell. Okay, this is the electrochemical cell overall equation. The standard cell potential E naught cell is equal to 0.51 volt. Find the cell potential E cell if the Ni2 plus concentration is 5.0 molar and the zinc 2 plus concentration is 0.05 molar. So what should you do first? So first of all, you have to find out half cell for the reduction and half cell for the oxidation. So it is based on the oxidation number. When we compare zinc 2 plus, so there is increasing of oxidation number from 0 to 2 plus. So therefore, zinc is undergoes oxidation. Okay, and then for the Ni2 plus, we can see from Ni2 plus produce Ni solid, there is a reducing in oxidation number. So that's why Ni2 plus undergoes reduction. So from here, when we cancel out the number of electron of the both side, So we will get this overall. So for the Q, remember, solid is not considered in the reaction quotient, only aqueous. And remember, concentration of the product is divided by concentration of the reactant. Since both product and reactant have coefficient 1, so therefore it's power of 1. And the number of electron transfer here is referred to n equals to 2. And then write the formula, Nernst equation. And you have to substitute the value of Q here. The Q expression, you have to write the exactly like this. You cannot write just general log Q. So because the overall equation is already given in the question, right? Okay, next, substitute all the values. The E0 cell is already given, that is 0.51 volts, right? So N is equal to 2. Okay, and then concentration of Zn2 plus is referred to 0.05. Concentration of Ni2 plus is 5.0 molar. And you will get the E cell is equal to 0.57 volt. Right, so there are 3 factors that affecting the cell potential, E cell. So, because of that, you have to refer to this Nernst equation. Okay, in terms of temperature, okay, at lower temperature, the term of NT over NF ln Q becomes smaller. So, the magnitude of cell potential increase. So, E cell will increase. So, we can conclude that temperature is inversely proportional with the cell potential, E cell. Okay, for the second factor, in terms of concentration, so if the concentration of the reactant increase, so it will cause the term of NT over NF ln Q to become smaller. The magnitude of cell potential, that E cell, will increase. So we can conclude that the concentration of reactant is directly proportional to the E cell. Okay, next, what will happen when the concentration of the product increase? So as we increase the concentration of the product, it because the term of NT over NF ln Q become larger. So the magnitude of cell potential E cell decrease. So we can conclude that the concentration of product is inversely proportional to E cell. Okay, in terms of type of house cell use, okay, in terms of cathode, using a more positive electrode potential electrode as a cathode, it will cause the E0 cell increase. E0 cell will increase. So the magnitude of E cell will increase. So we can conclude, electrode potential of cathode is directly proportional to E cell. As for the anode, using a more positive electrode potential electrode as anode, so it will cause the E0 cell decrease. E0 cell will decrease. So the magnitude of E cell also decrease. So we can conclude that electrode potential of anode is inversely proportional to E cell.